नमस्कार माझ्या मित्रांनो आणि मैत्रिणींनो. मी आशा करतो की तुम्ही सर्वजण आहात त्या ठिकाणी खूप चांगले असाल. So last time we have seen how to get the data, okay, and then what are the things to taken care to analyze a preliminary analysis of the data. Okay, due to the as the video was longer, okay, recording was longer, so I have skipped a few information about the splitting. But don't worry, I'm covering here. That's why I mentioned his 2.2.1, okay, not 2.3. In coming lecture, we will definitely do the visualization in very detailed manner, and we will also see the correlation between different features. Accordingly, we will take the further action. But just to cover up the remaining part of the last video, I'm explaining here. So focus area to understand when we are doing the splitting of the data, we generally use a train test split. Okay, but is it always a good steps or good criteria to use a train test split, or is there any better solution apart from train test split? So don't worry, I'll explain in detail. Just stay and don't skip any part of this video. Okay, let's move to the next part. Yeah, so let me jump to the Collab notebook so that I can explain that portion. Okay, so here last time, as I explained already, we are just I'll just go through the notebook step by step, so it's just a 1 minute revision. Okay, we will just use the GitHub repo, download the data from GitHub repo. We will create our data set here, okay, and store it here. We will see the info. We have also seen the 5-point summary. 5-point summary is nothing but what is my minimum, what is my maximum, what is my 25 percentile, 50 percentile, 75 percentile, and max. What do you mean by percentile? Okay, that also I explained. If you still have any doubt, please go and watch the previous video. Okay, and then after that, we use matplotlib to draw this histogram. Okay, but we also understand the difference between the standard deviation and the variance, and what is the intuition behind that, and what is the exactly difference between that. So not giving much more time on the already done part, let's focus here. So guys, if you look at this diagram, this histogram, you will come to understand that if you look, let me just take the pen here. If you look at this median house, okay, median house price is only up to the something 1 2 3 4 5, yeah, it's up to only $5 lakh. Okay, it is not more than $5 lakh. So does it mean that my housing price fall in that districts, okay, fall in that districts is not more than 5 lakh? Is it something like that? Similarly, I found that there is a this median age, housing median age is not more than 50. So doesn't mean that is whatever houses are there in all the district of that state, not more than 50. Is it something like that? So graph tell me this kind of analysis. So graph is not just showing the pictorial representation. Graph is giving us that kind of analysis. That kind of analysis is not possible with the tabular structure. So when I look at each and everything, I understand that the median age and the house value is only limit to the particular value. Okay, so it is very important for me to go back to the client or stakeholder or whoever expert in that area and to understand, is it something like that? And then my client said, no, it is not something like that. My house value can be go beyond 50,000. My house value can go beyond the median age of 50. Okay, there might be house. So this is not the correct way. So what is the next solution? How you can reduce this kind of problem? So simple things, what you can do it, just collect whatever median age value which is up to 50, which is exactly 50, and collect the median housing value who are having the value of 5 lakh. Okay, collect those value and drop from the data. I really saying, I'm repeating myself. If you found any housing value which is equal to 5 lakh, find those value and drop those value. Why it is required to drop? Otherwise, your algorithm, when you pass this data to the algorithm try to learn the pattern. We understand already in our first lesson, algorithm always try to understand the pattern. And when you are giving any new house which is actual value is greater than 5 lakh, which is greater than 5 lakh, your algorithm tries to predict that housing value only till 5 lakh only. Okay, so it is very important, you must give the generalized value, otherwise your value will get predicted wrongly. Okay, so it is very most important, you have to do such a kind of analysis. Again, I'm repeating the solution is very simple. Collect those data which is equal to 5 lakh and drop them. Why to drop them? Just to make your model aware that my value can be anything greater than 5 lakh or can be lower than 5 lakh. I do not want to predict only till 5 lakh only. Okay, just to make my model generalized. So this kind of understanding you come to know after analyzing these graphs. I hope you understand. Okay, after that we have, let me clear the picture drawing. Yeah. After that we did the trend test split. So in the trend test split, generally people follow 80 to 20% of split. It is up to you how you want to do the splitting. You can go 60-40, 70-30, it's up to you. But in our case, we do the splitting 80-20%. That's why I have given here 0.2. So my test size is the 20%. I'm passing my data, original data, that is housing, and I'm giving random state 42. Now, what is the meaning of random state 42? Please remember, this is an arbitrary number. You can give any kind of a number, doesn't matter. But as a standard, people used to follow 42. So that's why I've given also 42. So when you mention the random state 42, it means that whenever you run this block of code, it will not change your test data. Now what happened? Let's say this is my data 1, number 2, number 3, number 4, number 5. Okay, and number 6. Okay, so from number 1 to 4 is my train, and from number 5 to 6 is my test. Okay, when I run this code without the random state, what happen if I run this code again? Next time what will happen? My 1, 2 it consider as a test, and 3, 4, 5, 6 consider as my train. Similarly, if you run it again, might be it will consider 3, 4 as my test and remaining number as a train. So what is the problem in this? The problem in this is that your test data is visible to your training data, means test data is also visible to your model, and we don't want that. We want test data must be as a test data, and my ML model never seen that data. Okay, otherwise my model see the test data every time, and it will not be become a generalized model. It will give the wrong result. So I always want to keep my test data as unseen data. It should not mix with my trained data. Okay, so that's why we have to give the random state equal to 42. Understood? To just keep the test data as it is. It should not be changed whenever you run this block of code. So when I run this, I always keep 5, 6 as a test data. Okay, always, even whenever you run this code, and my 1 to 4 as a train data only. So just to avoid this mixing of train and test data, okay, I'll keep this random state as 42. I hope you understand what is the intuition behind the random state. Okay, now this is just the calculation just to understand, yeah, is it my train test split is okay or not. Now there is one more important concept called as a stratified split. Now what is the meaning of stratified split? Before that, I wanted to explain one thing. When I was doing this analysis, someone came and explained me that the median income of people, okay, let me take the picture. Yeah, median income of the people has a very large impact on the housing value. Okay, it has a direct, you can say, relation. Those are having that high income having the high price value, those are having less income, there the price of the house is less, and we generally find that kind of stuff in our India as well. Okay, housing price is almost depend on the income. So it is very much important when I do the train test split, my test also has the equal amount of representation of my income. Now, what I really wanted to explain, I'll try to give the one more example. I already explained there was a one story, okay, which is I explained in one video. There was a survey conducted in US 1936. Okay, who won, Roosevelt or Landon? Okay, and as per the survey, it was predicted that the Landon won, but Roosevelt was won about almost I think 63% vote. Okay, so what happened actually? Whatever sample they have taken, okay, that sample is not a representation of all the peoples, because when the American voted, okay, that contains they have the representation from all the groups, but survey, after the analysis they found that the survey was taken only from the literate people who has the gadget, who has get the newspaper, who has a magazine subscriber. From only those people they have taken the survey, and because of that their analysis, their prediction is wrong. Therefore, it is very important that whenever you do the train test split, your test split must have the representation of all the levels from the train. So it is very important when I do the train test split, my test split must contain the category of all the median income people. So for that, I'm dividing, I'm creating one more feature called as a income category. Now I can see from the graph, my income category, mostly income category peoples are from 1 to 6 year. Okay, so my test split must have this category in equal proportion. Okay, I'll show you how we can get that equal. So for that, I need to convert this continuous value into the categorical form. Okay, so first of all, let me just come here. Okay, so to do this stuff, first I need to, okay, let me just, so I need to create the housing income category, because my test must contain those income category as well, so it must have the equal proportion. What do you mean by, I'll explain again in detail in minute. So income category, so for that I use pandas data frame pd.cut, which will convert my continuous value into the categorical form. And for that I use again housing, it's a housing, and I use median income. Okay, and I'll create the bins here. Okay, so what is the bins? If you see, it's from 0 to, so my 0 to 6 contains the most of, so I'll create the bins from, let me copy this only, so it's better to explain. So I'll create the bins from 0 to 1.5, 1.5 to 3, 3 to 4.5, 4 to 6, and it's NP. Let me just, NP is coming, import numpy as a NP. So here I'm making a bins, I'm making a category. Okay, and I'm giving those category label 1, 2, 3, 4, 5. So my one label contain the income from 0 to 1.5. My two category contain the salary income from 1.5 to 3, and my third category contain 3 to 4.5, and likewise. Okay, so just remember one more thing I miss, that here 1.5 is meaning that it's a $15,000. 3.0 means $30,000. 4.5 is the $45,000. Okay, so you must consider this as a in $1,000. Okay, so whenever doing this kind of stuff, the scaling things is also important. Okay, so when we will talk about the feature scaling, I will explain in that detail, but just remember the data which we have, it's in the thousand. It's not something that $1.5 is the salary. It's a $15,000 salary. It's a $45,000 thousand salary. Okay, so I'm just making the categorical representation. So from 0 to 1.5 having this much of people of salary. Let me run this code and then I'll explain the histogram. Yeah. So it's yeah. So this is the histogram. So from 0 to 1.5, I have, I think, more less than 1,000 people having salary. Okay, from 1.5 to 3, people's having less than 7,000 has the 7,000 people's earning the salary from 1.5 to 3. So this is a histogram representation. Okay, and I have created the label called as a 1 2 3 4 5. You can see 1 2 3 4 and the 5. Okay, let me type. So this is a 1 2 3 4 and 5. So I have created the 5 labels. So now I converted into the categorical format. Okay. Okay, next. So after that, okay, let me just use the stratified split. Yeah, so to use the stratified split is very simple. You just use this library from the sklearn. Okay, and then use the n split. N split is nothing, how many times you want to do the reshuffling. Okay, so I'm here using only one time reshuffle, not more. It's a simple as it is, and I want to create the test size as 20% of size, and then random state. So this way I did the splitting. Okay, after the splitting, it is very important to create the, now split happens, I create my test size as a 20% and my train size as a 80%. Okay, and after that, let's, yeah, again, it's an income cat. Yeah, so it's a train test index in split housing income. Okay, so I'm just looping this new category over this index, and just I'm allocating the data to the strat trend set and strat test set. Okay, so in this way I divide the data into the stratified manner. So there is one more thing. Stratified is nothing but the my all the categoricals have the, so my test size, my test data, and my income data has a equal representations. So what do you mean by that? Let me explain you. So suppose, see, okay, let me just mention this income category. So see, I have created the 5 labels, 1 2 3 4 5. Okay, 5 label of median income. So my 3 label contains 35% data, my second label contains 31% data, my 4 label contains 17, and my fifth is 11, and my one contains the 0.03% of data. This is what test representation of category. Now when I check the same stuff for the training, it must be a same. See, again, it's a income category. Yeah, see, now my training data also contain the equal representation of the this. So 3 contain 35, my second label contain 31, and not for the training, but my whole data contains the same representation. Yeah, so this way, see all the labels in my train data, in my test data, and my whole data contains the equal representation of all the data. So this way, stratified sampling ensure that, stratified splitting ensure that you have the equal representation and your prediction is not a bias. Now when I check, now we already created test split, right? Here, okay, let's check how much representation there in my train and test. Okay, so this is my train test. Okay, so and the length of is a train set. Okay, train set is not okay. I haven't run that code, so let me just run that first. Yeah, it's done. See, so my train set and so this is my total data. This is my train set. Let me check for the test set as well. Yeah. Now, if you look at this, how some this is a total data. This is my test data. Now you can find the difference between my test split and my total income data. Okay, so even there is a difference between your trend set and the test set. So this way I completed this today's lecture. It's all about how you can decide which split you must go, but mostly if it is a structural data and the categorical kind of prediction, I always say prefer the stratified split. It always overcome the uh, unbiasedness while doing the model prediction. In next video, we will see the visualization. Still, if you have any doubt about this, please feel free to comment. I'll try to explain there as well. Okay, I'll try to reply on that comment. Till that time, thank you guys and all the best.